Okay, so in this demo, I'll actually be following the Cloudskillsboost lab called Orchestrating the Cloud with Kubernetes. I put the link in the description of the video if you want to do this lab yourself. You will need a Cloudskillsboost account, although if you don't have one, you can get a free trial to run some labs. So let's get started. So the objectives of this lab are to provision a complete Kubernetes cluster using Google Kubernetes Engine. Then we'll deploy and manage Docker containers using kubectl, and we'll break an application into microservices using Kubernetes Deployments and Services. So to start off, let's activate Cloud Shell. Let's run a command to set the default compute engine zone. Then let's run gcloud container clusters create IO, which will be the name of our cluster. Now my cluster is ready, and let's now quickly check in the console by navigating to Kubernetes Engine. And here we can see the cluster that we just created with 3 nodes, which is the default number of nodes for a cluster. Here we can check some of the basic configurations, such as the Kubernetes version, the total number of nodes, external and internal IP addresses. We didn't specify any configurations when creating the cluster, so we got default values for all of these. Here you can also inspect the running nodes for that cluster. With amount of CPU, memory, and storage requested. Here we can inspect any storage volumes. Here we can see some observability metrics. For instance, CPU utilization. I don't have anything going in these clusters at the moment, so this will not be super interesting. Let's go back to Cloud Shell. Now download the sample code from the lab. Then I'll navigate to the right directory. Here we have a folder for deployments, pods, and service definitions. If we take a look, for example, at the deployments folder, we have a couple of YAML files here, which we'll be working with. Let me clear this up. Now let's run our first kubectl command, and that would be kubectl create deployment nginx. And with this, we're creating a simple nginx deployment. We can now run kubectl get pods to inspect the running pods for that deployment. We have a single pod in container creating status. If we run this again, now we have a running pod. Now let's say we want to expose that deployment using a service. We can do so by running kubectl expose deployment, the name of the deployment, the port, and the type of the service in this case, which will be load balancer service. Now if I run kubectl get services, I can see my nginx load balancer service with a pending external IP, which is still being created. There's a default cluster IP service here for internal connectivity within the cluster. Okay, now after about 50 seconds, we got an external IP, which we can now test by running curl on port 80. So this is the welcome page of the Nginx server. So it looks like our service is working correctly. Now we move on to something a little more interesting. So let's check a monolith pod definition that we have in this YAML file. And let's create this pod by running kubectl create-f to specify we want to create a Kubernetes object using a YAML file. And we provide the path for the file. Now if we run kubectl get pods, we can see our new monolith pod running. And this is using a particular image here with a very simple deployment of a monolith. If we run kubectl describe pods monolith, we get some more details about the pod, the current status and configurations, and we can also see some of the latest events and logs. Now let's see how we can interact with pods. So for that, I'll run kubectl port forward monolith. I'll specify a local port from the dynamic TCP port range and the port in the pod. What I'm doing here is basically using a local address and port to connect to my pod on the specified port 80. So if I now open a second terminal and I run curl http and my local host address and the port that I specified, I will be effectively connecting to the pod's port 80, which returns me this particular message here. Now that pod has a secure endpoint that requires authentication. If I try to access it, I get authorization fail. But I can try to go to the login endpoint. Then I'll type the provided password from the lab and I get a token. I can save this token to a variable by running this command here. Password again. And now if I run a curl by passing in the authorization token, then I can get the message from the secure endpoint, which I couldn't before. Now let's say we want to expect the logs from the application. So here we can see the HTTP requests that I've been making. These are basic web server logs. Another thing I can do is kubectl exec monolith. And this will allow me to SSH to the pod, which is my web server running my monolithic application. I'm going to type exec to go back to my Cloud Shell. Let me clear this up. And let's now move on to services. For that, I'll go back to my previous terminal. And now let's inspect the secure monolith YAML file. And I'll run a bunch of commands here to create some secrets and config map objects. Now let's explore the monolith service definition, which creates a service for the monolith deployment on port TCP 443 and node port 31000. And this is a node port type service, which will expose the deployment by exposing it via the IP address of the underlying node, plus the generated node port. So let's create the service. And here we need to make sure we have firewall rules to allow that traffic. On the node port Now we can find what the IP address of the node is by inspecting our Compute Engine instances. And here we can see for each of our nodes, we have an internal and an external IP address. So I could connect to my service by running a curl command against any of these IP addresses. For example, if we pick the first one and we add the node port. Now I got a connection refused, and that is expected because we need to do one more thing in order for this to work, and that is the next step in the lab. So let me clear this up. Let's run kubectl get pods, and let's filter by label by doing the -l option. App equals monolith. And here we have our two pods with the same label. And if we search by pods with both the label app equals monolith and secure equals enable, we don't get any resource. And if we inspect our service again, note that we do specify that this service is exposing deployments with both of these labels. Because it didn't find any, there aren't any pods that would be exposed by the service, which is why it didn't work. So what we need to do is to add labels to our pods. So we do that with kubectl label pods, and then let's add the secure equals enable label to our secure monolith pods. And the next command, kubectl get pods secure monolith show labels, will list the pod with all the labels in it. And now we have both of these labels in the pod. Now this pod should be exposed via the service. So let's test it again. And now we get our response. Once again, I could use any of the nodes IP addresses for this. So for instance, if I run gcloud compute engine instances list, I can rerun my curl command with this time a different node IP address. Let's say the last one, and we'll still get the response. So that's a node port type service where we can use any node IP address plus the node port that we specify, or which is dynamically generated if we don't specify. Now let's see how we can create a deployment on Kubernetes to deploy an actual application. Let me clear this up again. Let's inspect the deployments auth.yaml file. And here we have a deployment of a container with a particular set of configurations here, and including a readiness probe on the /readiness endpoint on port 81 using HTTP. Let's go ahead and create a deployment by using kubectl create-f and passing in the file. Let's also create the corresponding service for that deployment. And let's do the same thing with a separate deployment called hello, and specifying the hello.yaml files. Finally, we need to create some config map variables here, and also a front-end deployment service. So now let's take a look. We have a bunch of new services running. In particular, let's check the front-end service. And let's wait a few seconds until we get an external IP ready here. And now we can run curl and the external IP, and we get our response back. So what we just done was basically we broke down that same monolithic application into a microservices architecture by splitting up the monolith into multiple different services and deployments that are concerned with specific business functionalities of the application. In this case, we have a front-end component, we have an authorization component, and we also have a hello component, which is returning the message. Let's take a look at what it looks like in the console. So I'll navigate to the workloads dashboard here, where we can see all of our deployments, our single pod that we created earlier, and the other one here. We can also check the observability tab here. Now we can probably see a little bit more usage in the CPU dashboard. Number of cores, etc. For memory as well, we have some charts. Now let's go back here and try to inspect a specific deployment, for example, front end. And here we can see metrics specifically related to this deployment and the pods that are running it. We can see which pods are running it, which service is exposing it, TLS configuration, details, revision history, events, logs, any app errors, and the YAML file definition, which is expanded with the entire spec for the deployment. Over here we can inspect the secrets and config maps, some of which were created by Kubernetes itself, some of which we created. And over here we can inspect the services that we created, their endpoints, and we can also click on each of these and check more details about the services along with the deployments that they expose. So that's it for this lab, and I hope that was useful.